Hello, myself Raksa Patel. Hello, myself Raksa Patel, working as an assistant professor in computer department at Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Now today we are going to learn about part 6 of unit number 4. Today in this session we discuss about matrix chain multiplication using dynamic programming. First of all we see what is the multiplication. Now multiplication is to multiply the two given matrix. Let suppose there is an n matrix of a1 a2 up to an of dimension p1 cross p2 comma p2 cross p3 comma p3 cross p4 up to pn cos p of n plus 1 respectively. Now main goal of matrix chain multiplication is to compute the matrix product of a1 a2 up to an. Now main problem of matrix chain multiplication is in what order should the matrix a1 a2 up to an be multiplied so that it would take the minimum number of computations to derive the product. Let performing the matrix multiplication, the cost is, suppose there is a two matrix A and B with a dimension of P and Q and R. Whenever now main things of matrix multiplication is the column of first matrix and row of second matrix are same, then and then matrix multiplication is possible. To multiply A cross B here it is possible because the dimension of matrix A is 2 cross 3 and dimension of matrix B is a 3 cross 2. So number of column in matrix A is a 3 and the number of row in matrix B is a 3. So here multiplication is possible, but reverse multiplication is not possible always. Here it is possible because 2 cross 3 cross 2 and 2 cos 3 cos 2 and 2 cos 3 number of column and number of row are become same, but it is always not possible. Now here the matrix A has a dimension P and Q and matrix B has a dimension Q and R. So resultant matrix C is equal to A cross B. So C is the dimension of P and R. Here that is 2 cross 2. Suppose the matrix A has a dimension 2 cross 3 and a matrix B has a dimension 3 cross 2, then the product of matrix C is equal to A cross B and the dimension of matrix C, that is 2 cross 2. Now how many total scalar multiplication is required here? That is P into Q into R. So P into Q into R, that is 2 cross 3 cross 2. So the total number of scalar multiplication is 12. 12 scalar multiplication is required for resultant matrix of 2 cross 2. Now main aim of matrix chain multiplication is not to find out the matrix multiplication, but main aim is how to minimize the number of computations. So that is the main aim of matrix chain multiplication. Now we want to calculate the product of more than two matrices. Then matrix multiplication is associative. The product of four matrix, here we take the 4 matrix which is more than 2 matrix. The matrix of dimension A, that is 13 cross 5 and the matrix B is a 5 cross 89. Matrix C is a 89 cross 3 and the matrix D is equal to 3 cross 34. Now how to parenthesize the matrix multiplication which minimize the computations of matrix multiplication. Now here the 5 different way to multiply the 4 different matrix. The first is to first multiply the A cross B, to multiply the two matrix A and B, and the answer of this matrix to multiply with C, and this answer is multiply with matrix D. Now then these parentheses how much computation is required. Now see here, first multiply the A into B. The dimension of matrix A, that is 13 cross 5, and dimension of matrix B, that is 5 cross 89. So P cross Q cross R, that is 13 into 5 into 89 is equal to 5785. Now answer of this R1, answer of this is stored into suppose R1. So dimension of R1 become 13 cross 89. Now this multiply with the matrix C. So 13 cross 89 is multiplied with 89 into 3. So answer is stored into suppose into R2. So computation is 3471. Now this answer or this R2 dimension, that is 13 cross 3, is multiplied with matrix D. Now we multiply the 13 cross 3 with a dimension of matrix D, that is 3 cross 34. So computation is 1326. So how much computation is required? Make the addition of 5785 plus 3471 plus 1326. So total how much computation is required? 10582. Now the second way of multiplication, that is first multiply the A and B matrix and then multiply it with C and D. So it require how much computation? 54201. Now the third way is first multiply the B cross C, matrix B with C, and then multiply it with matrix A, and then multiply the whole answer with matrix D. So how much computation is required? 2856. Now the fourth way is multiply the B cross C and then multiply with matrix D, and after that multiply with matrix C. So how much computation is required? 4055. Now in fifth way, first multiply the matrix C and D and then it multiply with matrix B, and after that whole answer is multiply with matrix E. So how much computation is required? 26418 computation is required. Here the computation, second computation, that is first multiply the matrix AB and then multiply it with C and D, which is much cheaper to compute the this one. A, first multiply the B with C and then A and then D. So here less computation is required. How much? 2856. So this is much cheaper and this is less cheaper. So this is defined how to minimize the number of computation. So we solve it with the dynamic programming. Now first of all we generate the table or matrix. For that we make the matrix table M of ij's to store the cost of multiplication. For that we have a number of steps. The first step is if I equal to j, then M of ij is become 0. If j is equal to I plus 1, then M of ij, that is matrix table of ij, is equal to P of I minus 1 dot P of I dot P of I plus 1. If I is less than j, then M of ij is equal to minimum of minimum of this one. I to k plus M of k plus 1 to j plus P of I minus 1 dot P of k dot P of j with I is lesser or equal to k is less than j. Minimum is found with the different value of k. Now we see the example using dynamic programming. Here we take the 4 matrix matrix A has a dimension 5, 4. Matrix B is a 4 cross 3, 6. Matrix C is a 6 cross 2. And matrix D is a 2 cross 7. Here we take the dimension. The first dimension P0 is a 5 and P1 is equal to 4. P2 is equal to 6. P3 is equal to 2 and P4 is equal to 7. Here 5 dimension with the 4 matrix. Now first of all we may generate the table. Here step 1 is if I equal to G, then M of Ij is equal to 0. Means M of 1 1 is equal to 0. M of 2 2 is equal to 0. M of 3 3 is equal to 0 and M of 4 4 is equal to 0. Means make the diagonal 0. So we put here 0. Now the second step is if j is equal to I plus 1, then M of Ij is equal to P of I minus 1 into P of I into I plus 1. Now first we found the M of 1 2. Here j is equal to I plus 1. Value of I is equal to 1 and the value of j is equal to I plus 1, that is 2. So for that we found the M of Ij is equal to P of I minus 1. Now what is the value of I? That is 1. 1 minus 1 is equal to 0. So P of 0 into P of 1 into I plus 1. What is the value of I? That is 1. 1 plus 1 is equal to 2. So M of 1 2 is equal to P0 into P1 into P2. Now what is the value of P0? That is 5. P1 4 and P2 6. 5 into 4 into 6. It becomes 120. Now cost of matrix 1 and 2 multiplication is 120. Now similarly for matrix 2 3. M of 2 3. So we multiply the matrix B and C. Matrix 2 and 3. So for that here value of I is equal to 2 and value of j is equal to I plus 1, that is 3. So P of I minus 1 into P of I into P of I plus 1. So it becomes P1 into P2 into P3. So P1 is equal to 4 into 6 into 2. So cost multiplication is 48. Now similarly for M of 3 4. For M of 3 4, here I is equal to 3 and j is equal to I plus 1. 3 plus 1 is equal to 4. So M of 3 4 is equal to P2 into P3 into P4 becomes 6 into 2 into 7. So cost multiplication is 84. Now whenever if I is less than G, here we found the M of 1 3, value of I is equal to 1 and value of j is equal to 3. So I become less than G. For that found the minimum of M of Ik plus M of k plus 1 j plus P of I minus 1 dot P of k dot P of g. Now here I is less than G. For that for I equal to 1, j equal to 3. Now value of k become k is I is lesser equal to k and k is less than j. So k become less than j. Now k of value of k is equal to 1 or 2 for j is equal to 3. Now first of all we found the value for k equal to 1. So M of 1 3 for M of 1 3 is equal to M of minimum of M of Ik. Value of I is equal to 1 and k is equal to 1. So M of 1 1 plus M of k plus 1. K is equal to 1. 1 plus 1 is equal to 2 and value of j is equal to 3. M of 2 3 plus M of I minus 1. I is equal to 1. 1 minus 1 is 0 dot pk. Pk value of k is equal to 1. So P1 into Pg, value of j is equal to 3. So P3. So is equal to M of 1 1 plus M of 2 3 plus P0 into P1 into P3. So value of M of 1 3 becomes M of 1 1. M of 1 1 is equal to 0 and M of 2 3. M of 2 3 is equal to 48 into P0 is equal to 5 into P1 is equal to 4 into P3 is equal to 2. So 0 plus 48 plus 5 into 4 into 2. 5 into 4 is 20. 20 into 2 is 40. So 40 plus 40 is become 48. Now we calculate the same calculation for k equal to 2. Now m of 1 3 is equal to m of minimum of ik, value of I is equal to 1 and value of k is equal to here 2. So m of 1 2 plus m of k plus 1, k is equal to 2. 2 plus 1 is equal to 3 and value of j is equal to 3, m of 3 3 plus p0 into p2 into p3. So m of 1 2, m of 1 2 is equal to 120 and m of 3 3, m of 3 3 is equal to 0 plus p0 is equal to 5, p2 is equal to 6 and p3 is equal to 3. So 120 into 5 into 6 into 2, so it becomes 180. Now the less computation is found whenever k is equal to 1. So we put less computation. So we put the m of 1 3 is equal to 88. Now for m of 2 4, here also I is less than j. So I is equal to 2, j is equal to 4. Now value of k is equal to 2 or 3. Now first of all we found the m of 2 4 for k equal to 2. So m of I is equal to 2 and k is equal to 2. So m of 2 2 plus m of k plus 1. 2 plus 1 is 3 and j is equal to 4. M of 3 4 plus p of I minus 1. Value of I is equal to 2. 2 minus 1 is 1. P of 1 into pk. K is equal to 2 into pj. J is equal to 4. So P1 into P2 into P4. So value of m of 2j become m of 2 2 is equal to 0 plus m of 3 4. 3 4 is equal to how much? 84. 84 plus 4 into 6 into 7. So it becomes 252. Now we make the similar computation for k equal to 3. So it becomes how much? 104. Now we found the less computation 104. Whenever value of k is equal to 3. Now we put 2 of 4 is equal to 104. Put here 104. Now we make the calculation for m of 1 4. Now here I is equal to 1, I is less than j, I is equal to 1, j is equal to 4. Value of k become 1 or 2 or 3. Now we make the same computation for k equal to 1, k equal to 2 and k equal to 3. Here we already make the computation. Whenever we make the calculation for k equal to 1, it gives the 244. We found the k equal to 2, it gives the computation 414 and k equal to 3, it gives the computation 158. So here the less computation is 158 whenever the value of k is equal to 3. So we put 1 of 4 is equal to 158 in the table of m of I. So we put here 158. Now to multiply the 4 matrix A, B, C and D, how much computation is required? 158. Now the next question is to how to parenthesize that required computation 158. Now to how to parenthesize the 4 matrix A, B, C and D. For that we look at the table. Now the last table is to multiply the m of 1 4 and the computation is required less, that is whenever value of k is equal to 3. Now what is that? First multiply the 1 2 3 matrix. What is that? A, B and C. Now we multiply the A, B and C. Means parenthesize the A, B and C and then m of 4 4. Now we found we look at the table of m of 1 3. Now what is that? So m of 1 3, there isn't two computation, k equal to 1 and k equal to 3. Now which one is less? Whenever k equal to 1, it's required a less computation, that is 88. Now what is that? First, parentized m of 1 1 plus m of 2 3. So we parentized b and c. Here b and c. So it required the less computation. Now first we multiply the matrix B with C, and then we multiply with A, and after that we multiply with D. This gives the minimum computation. This is our answer to multiplication, how to parentize the matrix. Now here we give the example with the 4 matrix. The dimension of matrix 1 is 18 cross 4, with the matrix 2 4 cross 13, matrix 3 13 cross 7, and matrix 4 7 cross 15. So first of all, found how to found the optimal sequence, and then find the optimal parenthesis of matrices. Thank you.